A matrix is a rectangular arrangement of numbers. A matrix is arranged with rows and columns. The dimensions of a matrix tells us how many rows by how many columns. Each number in a matrix is called an element or an entry. So the matrix that I gave you here has 2 rows, 1, 2, and it has 3 columns. So we say that the dimensions is a 2 by 3 matrix, a 2 by 3 matrix. And if I wanted to know the element in row 2, column 2, it would be 0. You can combine 2 matrices with equal dimensions by adding or subtracting the corresponding elements. So we can only add or subtract matrices that have the same dimensions. And when we add or subtract matrices, we add the corresponding elements. The corresponding elements are the ones that are in the same position in each matrix. So let's look at the example. I've given matrix A and matrix B. Matrix A is a 2 by 2 matrix because it has 2 rows and 2 columns. Matrix B is also a 2 by 2 matrix. So they have the same dimensions. Therefore, we can add and subtract them. So when we add and subtract, we're just going to add and subtract the corresponding entries. So I'm going to say that 3 plus 1 is 4. 2 plus 4 is 6. 4 plus negative 2 is 2. And negative 1 plus 2 is 1. And then if we want to do A minus B, we're going to subtract the 2 matrices. We're going to subtract the corresponding elements. 3 minus 1 is 1. 2 minus 4 is negative 2. 4 minus negative 2. Be careful when you're subtracting a negative. 4 minus negative 2 is 6. And negative 1 minus 2 is negative 3. So that's pretty straightforward. When we add and subtract matrices, we add and subtract the corresponding elements. And so the question is matrix addition commutative? So in other words, is matrix A plus B the same thing as matrix B plus A? And the answer is yes. Yes. Matrix addition is commutative because matrix A plus B is the same thing as matrix B plus A. But subtraction, matrix subtraction, is not commutative because matrix not commutative because matrix A minus B would not be the same thing as matrix B minus A. So we can do matrices on our calculator. We pull up our calculator. I've already shown you how we can put a matrix into our calculator. We go to second matrix, which is the X to the little negative 1 button, and we go to edit. We can change the matrix to be whatever dimensions we want, and then we can put the elements in that matrix. So let's put in matrix A and matrix B, and we can do operations with our matrices also. So there's matrix A, and now I'm going to go back to matrix. I'm going to go to edit and go down to matrix B and put in a 2 by 2 matrix and put in the elements from matrix B. And so now if I want to do some operations with these 2 matrices, I can do it in my home screen. I always do operations in my home screen. So I'm going to go back to matrix, stay in the names column, and do matrix A plus, and then go back to matrix, stay in the names column, go to matrix B, and there we go. A matrix equation is an equation in which the variable is a matrix. You can use the addition and the subtraction properties of equality to solve a matrix equation. So if we have matrix B and C given, then and A minus B is equal to C, then what is A? So I'm going to write my equation, A minus B, which is a matrix, is equal to C, which is another matrix. And to solve this matrix equation, I have to add this matrix to the other side of the equation to solve for matrix A. So So we're going to add these two matrices together. So first we have to check their dimensions to make sure that they have the same dimensions. So we've got a 3 by 3 with another 3 by 3. So I can add these together. So matrix A will be a 3 by 3 matrix also. And we're just going to add the corresponding entries. So we just go through and we add the corresponding entries like that. So equal matrices have the same dimensions and equal corresponding elements. For example, these two matrices are equal because their corresponding entries are exactly the same. They have the same value. 0.25 is the same thing as 1/4. 1.5 is the same thing as 1 1/2. And 4/5 is the same thing as 0.8. You could use the definition of equal matrices to find unknown values in matrix elements. So here's an example. What are the values of x and y? What values of x and y make the equation true? Well, let's see. Since this element corresponds with this one, I'm going to write 3x plus 1 is equal to 16. And since this element corresponds with this one, I'm going to write 2 minus 1 is equal to negative 5. And then I'm going to solve for x, and I'm going to solve for y. So I get x equals 5, and I get y is equal to negative 2. So if two matrices are equal, we know that their corresponding entries are the same. They're equal. So we can use that to solve for variables. A real number in matrix math is called a scalar. Multiplication of a matrix by a scalar, C, is called matrix multiplication. So if we want to multiply a matrix by, let's say, 4 or 5, we just multiply each entry by the scalar. That's all we do. So let's look at the example. We've been given matrix A, and we've been given matrix B. And we want to know what is 4 times A plus 3 times B. So I'm going to do 4 times matrix A. So I'm going to take matrix A and multiply it times 4. So I'm going to multiply everything times 4. -4, 20, and 8. And plus, and then 3 times matrix B. So I'm going to take matrix B and multiply it by the scalar of 3. So I'm going to get -3, 0, 15, 0, 9, and -6. So now I'm going to add these two matrices together. So first we have to check to see if their dimensions are the same. So I've got a 2 by 3 matrix with another 2 by 3 matrix. So since the dimensions are the same, I can add these together, and I will add the corresponding entries. 8 plus -3, 32 plus 0, -12 plus 15, -4 plus 0, 20 plus 9, and 8 plus -6. And that's it. Okay. And another equation to solve. What is the solution of 2x plus 3 times this matrix is equal to another matrix? So we're going to do all the operations here. We're going to multiply this matrix by a scalar of 3. So that becomes this. And then I'm going to subtract this matrix from both sides. So I have to be careful because I'm subtracting. 8 minus 6 is 2. 5 minus -3 is 8. 11 minus 9 is 2. And 0 minus 12 is -12. And then I have to divide both sides by 2. So dividing a matrix by 2 would be the same thing as multiplying the matrix by half. So I'm actually going to multiply by a scalar of a half. So I get another matrix, which is 1, and then 4, and then 1, and then -6. And that's it. So the last thing I want to talk about is matrix multiplication. So this gives us a little steps on how we do the matrix multiplication. But first, let's talk about if the matrix multiplication is even possible. If the dimensions of matrix A, let's say I have matrix A and matrix B. The dimensions of matrix A are an m by n, and the dimensions of matrix B is n by p, then the matrix multiplication is possible because the number of columns in the first is equal to the number of rows in the second. So as long as the columns, remember this is rows by columns. That's how we describe matrix dimensions, rows by columns. And this is rows by columns. So if the columns in the first is the same as the number of rows in the second, then the matrix multiplication is possible, and the dimensions of A times B will be an M by P. Rows from the first, columns from the second. That's how we know if the matrix multiplication is even possible. So let's look at the example. Matrix A is a 2 by 2. So we've got a 2 by 2 matrix. And B is also a 2 by 2. So the columns in the first is equal to the rows in the second. So therefore, the product will be a 2 by 2. So I'm going to make a chart. And I'm going to use these are the rows. So I'm going to use the rows from the first matrix. 2, 1 is the first row, and negative 3, 0 is the second row. And then the columns from the second matrix. So it'd be negative 1, 0 down, and then 3, 4 down, like that. And what we do is the entry that goes here, we use the first row, first column. First row, first column, 2 times negative 1 plus 1 times 0. 2 times negative 1 plus 1 times 0. 2 times negative 1, negative 2 plus 0, which is negative 2. That's how we get our entries. Let's go to first row, second column. So we use the first row and the second column. 2 times 3 plus 1 times 4. 2 times 3 is 6, plus 1 times 4 is 4. 6 plus 4 is 10. And we'll go to the second row, first column now. Negative 1 times negative 3 plus 0 times 0. So that would be 3. And then second row, second column, we'll use the second row, second column. Negative 3 times 3, negative 9, plus 0 times 4 is 0. So that would be negative 9. So my product matrix looks like this. So lastly, if I give you these three matrices, do the following products exist? Matrix A times B. So A times B, A is a 2 by 2, and B is a 1 by 2. So since these two columns and rows are not the same, we're going to say no, the product does not exist. And then B times A, B is a 1 by 2, and A is a 2 by 2. So now the columns in the first is the same as the rows in the second. So the answer is yes, and the product would be a 1 by 2. And then A times C, A is a 2 by 2, and C is a 2 by 3. So the product does exist, yes, and the product would be a 2 by 3. C times A, so there's 2 by 3, C, A is a 2 by 2. So the columns in the first is not equal to the rows in the second, so we're going to say no, the product does not exist. And then lastly, matrix B is a 1 by 2, matrix C is a 2 by 3. So the product does exist, and the product would be a 1 by